Hello and welcome to section 11.8. This is multiplying and dividing radical expressions, and this is the first video. This video will cover primarily multiplying radical expressions. And if you remember those radical expressions, they are those situations where we have a square root involved. And so we're going to be multiplying them to figure this all out. So multiplying square roots, that's where we're going to start. We have the square root of 3 times the square root of x, or square root of 3 times the square root of 6. Looking at this, we can think of this as being reverse of the product property of square roots. If we think about that product property, we can think about breaking down two numbers and turning them into two square roots and potentially solving a problem like that. In this case, we actually have it already broken down into two square roots, and we know we can't do anything with the square root of 3 or the square root of 6 besides putting it into a calculator and finding out what it is. However, what we can do is we can reverse the process of breaking them apart. We can actually say this is really the square root of 3 times 6, which is the square root of 18. And from there, we can actually see that there's probably going to be an easier way to break this number up so we can simplify it better. The square root of 18 is essentially 2 times 9. So we can rewrite this now as the square root of 2 times 9, or 18, and then say the square root of 9 will come out and it'll become a 3, and we can say 3 square root 2 is our final answer. So that 3 is square root of 3 square root of 6 turns into 3 square root 2. Let's do this for a couple more problems. We have we have 5 square root 3 squared. So essentially when we see a squared, that means everything inside that parentheses that's being squared is being squared. So we have 5 square root 3 times 5 square root 3. So essentially we're just writing that 5 square root 3 twice. Same thing as squaring it. So from there we can focus on the whole numbers. And since we're multiplying things, we can rearrange everything any way we would like, as long as we're not changing the entire problem. We can rearrange things based on the commutative property. So I'm putting my 5s out in front, and I'm going to do that math. And then I'm going to put my square root 3s in the back. So they're next to each other. Just kind of keeps things a little bit more organized. So we have 5 times 5, which is 25. 5 times 5, which is 25, and the square root of 3 times the square root of 3, which is essentially the square root of 3 times 3, and that is equal to 25. Square root of 3 times 3 is the square root of 9. If we took the square root of 9, we get a 3 out of there. Oops, that's not a good 3. So our final answer for this is 25 times 3, or 75. Let's try another problem. Here we go. 2 times the square root of 8x times the square root of 4x. We can do this multiple different ways. However, I'm just going to show one way. If you think about these square roots in any other way, don't think you're wrong. Let's just hope that we can get to the same solution. Okay? So we have 2 times the square root of 8x times the square root of 4x. I'm going to put that 8x and the 4x into one giant square root symbol, so that way everything's kind of in the same format. I'm going to say 8 times x times 4 times x. The reason why I broke it all up like that is so I can see that it's all being multiplied, and I can rearrange things the way I want to. I'm going to put my 8 and my 4 together, and then I'll put the x's together in my next step. So I'll have 2 times the square root of 8 times 4, and x times x, which I can also rewrite as x squared, all underneath the square root symbol. If you notice, this 2 that we have here is just going along for the ride. It's just hanging out. It's going to continue hanging out until maybe our last couple of steps. So we have 8 times 4, which is equal to 32. So we're going to now write 32 in here. We have our x squared, and we're going to take the square root. So the square root of 32, we need to break that up into a couple of squared numbers so we can actually play around with it. Before we had 8 times 4, and we know there's two 4s. There's one 4 inside of the 8 as a factor, and there's one 4 just in 4 itself. So if we actually think about it, 4 times 4 is 16, so 2 times 16 is 32. Can play around with that whole idea. So we have 2 times the square root of 2 times, oops, I should do that in the right color. Oh well, it's too late now. 2 times 16 times x squared. And now we can do a little bit of math action. 16, the square root of 16 is 4, and the square root of x squared is x. So the only thing that's left behind in this equation inside of the square root symbol is a 2. So it seems like we have a lot of 2's going on. We have a 2 on the outside that is now being multiplied by a 4, so 2 times 4 is 8. We have an x, and we have the square root of 2. So here is our final answer. Now there's a couple other ways that we can use multiplication with radicals. We can also multiply using the distributive property. So getting back to our roots at the beginning of the year, we can use the distributive property to distribute this 2, or a square root of 2 inside of our equation. So we have the square root of 2 times 5 times square root 12. Let's use that distributive property to multiply that square root of 2 by 5 and that square root of 2 by 12. So we can rewrite this as 5 times the square root of 2 plus square root of 12 times the square root of 2. So that 5 square root 2, that's pretty much all we can do with this information as of right now. But square root of 12 times the square root of 2, we can actually do something with that. That square root of 12 times 2 is going to go into that radical sign altogether. So all of this is then equal to 5 square root 2, as always. Square root of 12, if we do this math right here, we have 24, plus the square root of 24. 24, we can break that down into a 4 and a 6. That means we can say that this is equal to 5 square root 2 plus square root of 4 times 6. Square root of 4, if we were to bring that out, we get a 2. So let's give us a little bit more room. We have 5 square root 2. It's just hanging on with us this whole time, plus 2, which was brought out because of the 4 here, 2, and then the square root of 6. Final answer. And the reason why we know it's the final answer is there is no, these are unlike radicands, and they are also in their simplest form for square roots. There's no squared numbers inside of 2, and there's no square root numbers as factors of 6 either. So we are finished with that problem. Let's try another problem. We have the square root of 3 times the square root of 3 minus the square root of 5. So let's do a little bit of FOIL here. We're going to do the square root of 3 times the square root of 3 minus the square root of 3 times the square root of 5. So that 3 has been square root of 3 has been distributed in. So let's do a little bit of math. We have the square root of 3 times 3 plus the square root of 3 times 5. Square root of 3 times 3 means the square root of 9 plus the square root of 15. Can't do anything with that square root of 15, but the square root of 9, that becomes a 3. So our final answer for this is going to be 3 plus the square root of 15. Done. Let's try one last method, and I know you saw this at the top. So using the FOIL method. We've done this with binomials, and the reason we're doing it with radicals now is because radicals aren't quite the same as whole numbers, so they can't be treated quite the same. We know that a like radical needs to, or like radicand needs to happen for things to be added. So if we look at this situation, we have 4 plus the square root of 3. That's as simplified as that statement can get. There is no other simplification that can happen there. But at the same time, we're being multiplied by the same sort of situation, 3 plus the square root of 3. So we have to use FOIL to be able to get this thing done. So starting out, first means we're multiplying our first terms, 4 times 5. Then we have outside, 4 times square root of 3. Our inside terms, so plus 5 square root 3. And the reason why I say not square root 3 times 5 is it just sounds a little bit better when I say 5 times the square root of 3. And then last terms, so plus the square root of 3 times the square root of 3. So let's do a little bit of simplifying here. 4 times 5, that simplifies to be 20. So we have 20 plus 4 root 3 plus 5 root 3. I know you're probably saying, but we can add those, and that's awesome that you're seeing that. And then we have the square root of 3 times the square root of 3, which we can write as 3 times 3. Square root of 3 times 3 equals 9. So that means if I were to take those 2 3's out, those pair of 3's, we can say plus 3. Now let's add like terms. So that's where we can pay attention to those like radicands. Here's one set of like radicands, the square root of 4, or 4 square root 3 plus 5 square root 3 equals 9 square root 3. And then we have other like radicands, 20 and 3. Those are technically radicands. Why not? They have a radicand of square root 1 maybe after them, and square root of 1 is 1, so it just isn't written. So 20 plus 3 is equal to 23. So our final answer here is 23 plus 9 square root 3. And we are all done with that problem. Let's do one more so we can see how this method works one more time. So here's a practice problem. We have the square root of 4 square root 5 plus square root 5 times 3 minus square root 5. What I do like about this is I see square root 5 is on the end right there, and then what I also see is this plus and the minus, so I know something might maybe not necessarily disappear because we don't have the same front term, but it's going to be subtracted, and that's kind of fun. So let's get started. Our first terms, we're going to say 4 times 3, and then we have our outside terms. So 4 times the square root of 5. Our inside terms plus 3 square root of 5. And our last terms. Ooh, I did that wrong. If you noticed, I said for our outside terms, I said 4 times the square root of 5, and it's actually the square root of negative 5. So this should be a minus sign. So it's a negative 4 root 5. And then we have our 3 root 5, which is perfectly fine. There was a positive number there. And our last terms, 5 times the square root of negative 5. So that's negative square root 5 root 5. So let's finish this baby up. 4 times 3 is 12. We have a negative 4 root 5. We have a positive 3 root 5. And negative 5 times, or the square root of 5 times 5, which is 25. So we can do a little bit of math work there. Square root of 25 is 5. So 12 minus 4 root 5. Ooh, that's not a 5, that's a 3. Sorry. 5 plus 3 root 5 minus 5. Let's find our like terms. 12 and negative 5, those are like terms, so we get 7. And we have negative 4 root 5 plus 3 root 5 is negative square root 5. So 7 minus square root of 5 is our final answer for that problem. Kind of cool. Well, I hope this helps you with your Upcoming homework assignment. Homework is due on Tuesday. We are going to talk about it in class. So if you have any questions, make sure you ask them before you are expected to turn the homework in. Thanks so much for listening, and I'll see you later.